So for means, up here, I have two different blanks. So if we are dealing with means, why did I leave two separate blanks? And how do I know which one, what am I going to be given to know which path to take? So what should I write up in those little boxes up top?
If sigma's known.
So sigma known and sigma is unknown. Sometimes I say known and unknown, and sometimes I say given, not given, but that's obviously the same thing. What is my confidence interval equation when sigma is known? So what does confidence interval equation start with? I'm dealing with means before that, which is, so it's x bar what? So when sigma is known, I use z. What goes here? Which changes slightly. What change? Do I still use x bar for the second one?
Yes.
Do I still use plus minus?
Yes.
Do I still use z? I use what instead? Do I still use sigma? And do I still use square root n? So here I had the option of sigma known, sigma not known. But proportions, it's just proportions straight through. So instead of x bar, I'm using what? Still doing plus minus. What always goes here for proportions? And then now instead of being standard deviation over square root n, what is my equation here?
Square root of t hat times 1 minus t hat over.
So those are our three different confidence interval equations. So then the next one is just understanding terms and which part of it is that. So what is my margin of error for my first one? Starting at what? Taking the equation I just wrote down, that equation, which section of it is margin of error? So it's that section, everything past the plus minus of all these. So what's my margin of error for the second one? T star times S over square root n. And then what would it be for the last one? What does standard error mean?
Isn't that
Using
it, but without the z and t?
It's without using the ZT part, but also when you use a statistic to estimate for a parameter. So I'm going to start backwards here. I'm taking out the critical value. In this part of the equation, have I used a statistic to estimate a parameter? I've used p hat to estimate p. So the standard error is p hat times 1 minus p hat over n. For the middle one, I'm taking out my critical value. In this section, have I used a statistic to estimate a parameter? Yes. I've used S to estimate sigma. In the first one, I'm taking out my critical value. Have I used a statistic to estimate a parameter? I'm gonna write sigma of x bar, but it's not like so here it's sigma of p hat, but we just don't call it standard error. It's just still standard deviation of the statistic. All right, so that's all equation stuff. Now, other parts of the 4-step. State, obviously we're using the word mean or the word proportion. That's the only difference. Plan, my method is going to slightly change. What method do I use finding this first column? One sample, Z star, what?
Interval for means.
How does that change when I go to the middle one?
It's T star instead of C star.
It's just T star instead of Z star. So it is still a one sample. It is now T star, but it is still an interval for means. And then for my last one, am I still dealing with one sample? Yes, so it's still one sample. I do not have a decision here. It is always going to be which critical value. We are still doing an interval, but now it is an interval for proportion. Random stays the same, independent stays the same for all three of these. So the thing that changes is my normal condition. So why did I not separate these two for normal? It's all the same for both of those. As long as you're dealing with mean, you're finding normal the same way. So with this one, I have options. How many options do I have for means for normal? 3. What's one of them? Stated what? What is approximately normal? So don't just say stated, it has to say stated population distribution is approximately normal or normal. So that's one of my easy ways. What's another way?
Histogram.
I'm going to go in between. So histogram's down here. I'm going to go with the next easy one first. Central limit theorem, which is, what do I write beside of that?
N is
Which n? Little n is greater than or equal to. Or if neither of those work and I'm given all the values, I would graph a histogram of what? So I'd actually graph the histogram of values. And then I would check two things. What's one of the first ones?
Symmetrical.
So it's good if it's fairly symmetrical. It has to at least not be what? Can't be extremely skewed. And what's the other thing?
No extra.
No extreme outliers. And so again, in both of those, realize I'm using things like strong and extreme. If it's a little bit skewed or there's one outlier that's not that far away, we can make it work. And I'm going to write my last thing all the way across the bottom, so I'm not writing it twice. What do I check here? for proportions, so this is one of the most common mistakes in this class for second semester. Can I ever use central limit theorem for proportion? No, you cannot ever use central limit theorem for proportion. So how do I check for proportions or for normal for proportions? N times p hat has to be, and then this is the there are at least 10. Success and failure. And then what can I write all the way across the bottom of this? Because that's going to have to be there regardless. So the other things that I didn't write, I just chose not to write them. Why? Because they're the same for all three. Normal, same for all three. Independent, same for all three. Technically, state and conclude are a little bit different, but that's just the word mean or proportion. And then so I separated this bottom part because I don't want this is not part of the fourth step. Is the only reason I separated it. So if I am dealing with means, what equation am I using to find minimum sample size? Lowercase n is greater than or equal to what? As opposed to the one we just learned, if I'm doing it for proportions, I want lowercase n to be greater than or equal to and that whole denominator portion works. So this is hopefully just helping you kind of differentiate which things change and which things don't, and when to use which one where.